In this video, we're going to discuss two problems dealing with integration by parts. So the first one will be the integral of x cosine x dx. So as you know, the famous formula that we discussed in the previous video of u dv, okay, is going to be equal to uv minus integral v du. Okay, so one of the functions is a u in the given integrand, and one of the functions is a dv. So one function will be differentiated, and the second function will be integrated. So in this case, notice that your u, okay, is such that you will not have a u anymore in the integral when you subtract it in the integrand, right? So for your best sake, you need to choose the u carefully so that it will be reduced or become smaller. So in this case, we cannot choose the cosine as the u because in the end, uh, if we choose the du, right, the du will be negative sine x, and we will not go anywhere, okay? Because if we choose x and we try to integrate, if we choose x as the dv and try to integrate it, we will get 1/2 x squared, right? So we will not reduce it, but we will rather make it bigger than it should be, right? So we'll choose the u as the x because the du of x will be 1, right? And we want to have as few terms as possible in our next sets of integrals. Okay, so this is going to be 1 times dx, and dv is going to be cosine x dx, and the v is going to be simply sine x. Okay, so now this integral becomes x sine x, right? U times v is the x sine x, and no integral with that, right? Just the clean two functions u and v, right? Minus the integral of v du. V is the sine x, okay, and du is just 1 dx, right? So as you can see now, it's very easy to integrate sine x. We know that very well, right? So it's going to be x sine x minus negative cosine x, right? Because the antiderivative of sine x is negative cosine x. So then you will have a constant, so that's equal to x sine x plus cosine of x plus a constant. So there goes your antiderivative. Now the second problem will be the integral of x e to the 2x dx. So once again, we're going to choose the u as the x because it will disappear when it comes to the du in the integral, right? So u is equal to x, du is going to be equal to 1 dx, dv is going to be e to the 2x dx, and the v, the antiderivative of that, if you use the u substitution, you can put u is equal to 2x, du is going to be equal to 2, right? So you will have 1/2 e to the 2x, right? That's going to be the antiderivative. So now this will equal 1/2 x e to the 2x, right? U times v, right? Plain and simple, no integrals. This is not an integrand, right? This is just plain and simple product of two functions minus 1/2, we take it out, and then v du, we already took out the half, so it's going to be e to the 2x times 1, right? So e to the 2x dx. And we know how to integrate e to the 2x, so we'll keep going. 1/2 x e to the 2x. So as we already talked about, the antiderivative of e to the 2x is going to be 1/2 e to the 2x. So it's going to be minus 1/2 times 1/2 e to the 2x plus a constant. So that's going to give us 1/2 x e to the 2x minus 1/4 e to the 2x plus a constant. We can probably combine it by putting the greatest common factor outside. And we can have 1/2 x minus 1/4 plus a constant, right? So you can do it this way if you want. But basically, this will be your antiderivative. So thank you so much for watching. Please subscribe to my channel if you enjoyed it, and I'll see you in my next video.